Okay, welcome everyone. Thanks for being here today. Thanks for taking the time out of your busy schedules to join us for our webinar, How to Create Land Cover Maps with Higher Accuracy and Automation using our new machine learning classifier. I'm Mauro Scatoza, I'm your host. I'm the digital marketing specialist at PCI Geomatics, and I'm broadcasting the webinar live today from Ottawa, Canada. It's really great to see so many of you with us here today. We've got some really cool things to show you that we think you'll really like. But before we get started, I'd just like to go through some logistics. So all your lines will be muted during the presentation, but if you do have a question, if you have maybe some technical issues or something like that, please use the questions panel. You can raise your hand there, or you could just type in your question or your issue in the questions panel, and I'm going to be looking at that throughout the webinar, and I'll get to those as soon as possible. So the session is being recorded. We'll be sending out an email after the webinar with a link to the recording, but we've got some valuable information, some great content. We got a very cool demo to show you, so please stick around and enjoy the show. Okay, I'm going to introduce our presenters. Joining me today are two of my colleagues from PCI Geomatics, Jason Flatt and Sean Malamed. Welcome, guys. How's it going?
It's good to be here.
Thank you.
Awesome. There's Jason there. Jason, I'll start with you. So I understand you have plenty of experience with classification tools and land cover maps. So why don't you tell us a little bit more about yourself and about your experience?
Yeah, sure, of course. So my name is Jason Flatt, and I've been associate with PCI Geomatics for around 2 years. Through my time, I have developed our technology with different national and local agencies to leverage our capabilities and solutions to build and create different kinds of land cover maps.
Very cool. Okay, great. Thanks, Jason. Next up, we have Sean Malamed. How you doing, Sean?
Doing really well. Thanks for having me again, Mauro.
Of course, there you are there. Okay, so Sean, you and I, we work close together on the marketing side of things at PCI Geomatics. But unlike myself, you have a background in remote sensing. So why don't you tell us a little bit more about yourself and maybe some more information, maybe some more about your experience.
Yeah, absolutely. So I have over 10 years of experience in the remote sensing and geomatics field in general, all the way starting from when I was in school and university, majored in that, and then actually worked with PCI for 7 years to begin my career. And at that point, did a variety of different activities, such as development and a lot of customer-facing activities. So I have a lot of experience working with and understanding the problems and challenges of our customers and helping to implement our technology. Recently, I actually rejoined PCI about 2 months ago, and now within the capacity of product marketing manager. So I'm really looking forward to the opportunity to speak to our customers and learn more about how different people are using technology today. So once again, really excited to be here.
Very cool. Yeah, you were away. You were gone for a bit, but now you're back. So welcome back to PCI. Okay, so thanks, guys. So we're gonna look forward to your presentations. But before we do that, I'd like to just quickly go over the agenda for today. So in today's webinar, Sean will be giving you an introduction to Geomatica and highlight some of the new Geomatica features that we just released last week. He's also going to give you a background on land cover mapping, and then he'll get into some of the benefits of Geomatica, specifically for land cover mapping. And then we're going to get into a demonstration. Jason's going to give the demonstration. He's going to do a demo of the new random forest machine learning classifier we have now in Geomatica. And then we'll get into some questions and answers at the end of the webinar. Okay, so before I hand things over to Sean, I just want to outline a few takeaways. And highlight some of the things we're hoping you walk away with after this webinar. So first, we're going to be explaining some of the challenges of creating and updating land cover maps, and hopefully you'll gain a better understanding of this process. We'll also be outlining our vision for the future of land cover mapping and how Geomatica can add value into your data pipeline for creating land cover maps. Okay, so with that, I'm going to hand things over to Sean so he can go ahead and give that introduction to Geomatica. So take it away, Sean.
Thank you so much, Mauro. I appreciate that. So at the beginning right now, I'd just like to introduce a little bit more about Geomatica. So we may have some people on the line that are not as familiar with our Geomatica software offerings. So really Geomatica, it's a best of breed solution designed specifically around photogrammetry, remote sensing, and software applications and supporting technology to help with those workflows. And then ultimately delivering outstanding results for processing of satellite, aerial, and UAV imagery. So this is really what Geomatica specializes on. Now, with that being said, just looking a little bit more and pulling back the onion a little bit further, some of the key areas or the pillars that our technology is built around include photogrammetry, so looking at, say, survey accurate ortho images. So this is looking at sub-pixel accuracy, and we're going to actually showcase some of our industry-leading capabilities in this area. So generating those geometrically corrected imagery, once again, from all of those different platforms, as well as creating those precise and highly detailed 3D elevation models, both digital surface models, as well as performing the filtering activities to remove the surface features to create those bare earth terrain models. So we have a lot of technology just built into that pillar. Also, as we move over to the radiometry, so looking at the spectral information and the radiometry of the imagery, so we have a variety of different novel technologies looking at, say, image fusion capabilities. So we have a new image fusion algorithm that's designed to maintain the integrity of the radiometry of the image. Same thing with mosaicing capabilities, atmospheric correction, terrain correction. So we have a lot of different capabilities, and these all, once again, will show how these map back and are useful within the data pipeline for classification. Moving on, we also have a lot of technology and expertise within the radar realm, so looking at SAR and INSAR processing. So for those areas and those land covers that are constantly plagued by cloud covers, so it's difficult for optical sensors to be able to see through the ground, basically we can use radar. We have a lot of technology, once again, also within classification. And I think Jason is at least going to mention or showcase a little bit about how we can also use our object-based classifiers for SAR data as well. In SAR, we're going a little bit further into looking at the differometry of the imagery. So this is if you're looking to measure deformations such as subsidence and other deformation aspects. So we have the abilities there. And then finally, a large suite of capabilities around image analysis. So looking at turning your data into information. So looking at change detection, classification, analyzing vegetation, and a variety of other capabilities, which are also further supported by our machine learning methods. Also, just really want to highlight and mention our user interface and user experience. So we have a very responsive viewing and creating and editing environment where you can go in and interactively manipulate and validate the data sources and the creations and help create your different products. And then also automation is another key part of our environments in terms of both a programming API built off of through Python, so access through Python language, as well as our graphical environment for you to be able to drag and drop our different algorithms and functions and then chain them together into a batch processing workflow. So we have a variety of capabilities there. And then just a week ago, we released some new features, some exciting new features into Geomatica. So this includes over 30 new capabilities, sensors, and enhancements into our current Geomatica offering. So this is both available on our desktop as well as our cloud offerings. And then just to highlight a couple of different key capabilities that have gone in or new capabilities. So last week we showcased our end-to-end workflow for UAV imagery and some of the new tech that's gone in there in order to complete that workflow. And then today we're going to be showcasing the new random forest machine learning algorithm for classification and feature extraction using object-based methods. So just once again, this is going to be the purpose, and this is going to be the focus of this webinar is going to be on the land cover mapping and how our new random forest, which is called random trees, algorithm fits into this. So once again, this random forest algorithm is now available in our object analyst for a more graphical and interactive modeling method. Also available through our Python API for building into your data pipelines.
Okay, awesome. Thanks, Sean. Very cool. Okay, so at this point, we're going to get into the interactive portion of the webinar, and we'd like to ask for everyone's participation. And I'm actually going to be launching a poll. So let me get that started. Okay. So you should be seeing the poll on your screen now. So the question we're asking you here is, why are you interested in land cover mapping? So some of you, you might be working on a project to create or update a land cover map. Maybe you're about to start a land cover mapping project. Perhaps you need to use the results for your work. Some of you are interested in land cover mapping for educational or research purposes, and perhaps none of the above for some of you. In that case, please use the questions panel and you can specify your answer there. So just that's great. I really appreciate this the participation here. I'm just looking at the live results coming in right now. So thanks for your input on this. This is great. I'll let the poll run a little longer to bring in those responses. I'm seeing working on a project to create an update. So most of you are actually working on a project right now to create or update a land cover map. I'm seeing a lot of that. Some of you, actually some of you are interested in land cover mapping for educational purposes. Okay, this is great. I'm just going to let it run a little bit longer here. Okay, it looks like it's leveling off. Okay, I'm just going to close the poll. 5, 4, 3, 2, 1. Okay, here we go. Thank you for your participation. I'm just going to share the results there. So it looks like educational purposes. Some of you are working on a project right now to create or update a land cover map. So and some of you are just looking to use the results. So that's very interesting. So thanks again for participating in the poll. That's great. So I'm just going to close that out and give it back to Sean.
Wonderful, thank you, Mauro, and really appreciate once again everybody's responses. So at this point, we want to just provide a little bit of background on land cover mapping and how it's evolved and where it's at today, and how it's become a much more involved process than, say, 10, 15 years ago, when it was just taking single images and trying to run them through a supervised or unsupervised classification algorithm and pop out a result. And now it's become a fully involved data science project, which we're going to go into in a little bit, but just want to help educate some of those of you who may not be as familiar with some of the more novel and modern techniques being employed today. So just to start off with a little bit of background, we want to just highlight the scale is important. So there's a lot of different types of use cases and different types of land cover maps at different scales that are being created. So we have on the one end of the spectrum your global, continental, or national scale land cover maps. So a good example of that is the Korean land cover 2018, or all the different Korean land cover projects, the most recent one being in 2018. And just to look at some of the specifications so you can begin to get an understanding of what's involved in these projects. So in this case, this was, they were using mainly Sentinel-2 data and some Landsat 8 data in order to fill in the gaps. The project length, so these are long projects, 1.5 years. So we're going to talk a little bit more about that in a little bit. They have over 44 different mixed classes that they were going through, and the thematic accuracy that they were able to achieve was greater than 85%, geometric accuracy greater than 100 meters. Keep in mind they're using Sentinel-2 and Landsat 8 satellite imagery. And the minimum mapping unit that they were looking at, the minimum resolution was 25 hectares. So anything smaller than that would not be classified in this as a unique entity. And then just some other examples are the glob cover. So that's and then just to show you, it really varies in terms of the specifications. So that one's at about 90% accuracy. Then we have Red Plus programs, so a variety of different national scale land cover mapping projects, which really ranges depending on what level they're at in terms of Red Plus. So anywhere from usually 80 to 95%. Depending on what they're doing. And then another example of a national one, the 2015 Land Cover of Canada, which is done by CCMEO, and that had a requirement of 80%, and that was a part of a larger project for North America. And then if we look at a regional scale, we can look at, say, the National Capital Region in Canada. So this one was using a variety of different sources. The higher resolution was, in this case, UltraCam imagery. Project length, we don't have data on that here, but it uses 20 mixed classes at a thematic accuracy of 90%, geometric accuracy of 25 centimeters, minimum mapping unit, same thing, we didn't have any data on that. And then other examples include just more municipalities, so local authorities commissioning these projects for their areas and regions and land cover of interest, and then of course states and provinces, so other jurisdictions. So once again, these are just some, showing the range of scales that we can have, and that, different scales have different problems, different expectations. So now looking at a modern land cover mapping data pipeline. So once again, this really is very similar to a more, if you've heard the term data science project, and this is what we're starting to see, is these are true data science projects using machine learning and AI concepts. So just like a data science project, it starts off with the data selection. So often looking at a variety of different layers, no longer just using a single image or using single sensor, single mission, oftentimes trying to use multi-temporal data, different resolutions, different spectral bands, even mixing in SAR and optical. So all the different data types will have to is often selected at the beginning and figured out what they want to use and how they want to use those different products. Then it goes into the data pre-processing step. So this is really where you have, just like in data science, there's a common term, which is 80% of the work is in the data pre-processing step. So any of those of you who are actively working on land cover mapping projects today, you should be well aware that this is probably where you're spending a lot of your time. This is also in the post-processing. The classification modeling is actually probably one of the more faster parts. So this includes everything from creating that analysis ready data. So this is an area that we're going to talk a bit more about. So that geometric, radiometric correction, terrain correction, gap filling, doing data enhancement. So for example, image fusion, anything you could do to make it easier to extract and classify your imagery. And then also what's known as data or feature engineering. So this is basically creating new layers from your existing data, from your original data sources, such as, for example, time series analysis, indices. So those can be used to help understand the vegetation that you're looking at and compare, say, natural vegetation versus like agricultural land. So there's a variety of different novel methods that are being used in creating your information stack that you're ultimately pushing towards your classification and classifying models. So this is now where you're collecting your training sites and potentially importing them from field training sites that you've captured. This is where you're incorporating both modern concepts in AI, such as using deep learning neural networks, as well as machine learning classifiers, applying advanced modeling techniques. So just to give an example, you have model stacking as one of the more recent modeling techniques. This is where you're taking the outputs from different machine learning and AI models and combining them as inputs to new machine learning models and AI models. So you're creating very complex methods here And then of course, then there's the accuracy side, which is they're looking at reviewing the results, the ground truthing, they're looking at your control sites and validating. So this is generally a simplified but a more modern data pipeline in today's land cover mapping projects. So it resembles really that data, the data engineering, and data sciences. So now let's briefly take a look at how we benefit your land cover mapping project. So accuracy, fundamental to any land cover project. So this is an area that we'll peel back the onion in a little bit to showcase a little bit more about that. Automation and time savings. So these are long, large projects. Even the regional ones can take months, sometimes even years. We've talked to a variety of different municipalities and talked about some of the different land cover maps and challenges that they have. So these are big projects. Breadth of capabilities is another area that we can really help benefit. So we have over 550 different algorithms. So we're going to once again peel back the onion in a little bit, and we'll go into more depth about how we can support you and how our technology and best of breed technology is able to help support your data pipelines. And then integration. So this is another important area. So being able to take advantage of best of breed technology out there, both open source and commercial. Any model you look at, any methodology that you review in terms of how they generated their land cover maps, all the best ones in the world use a mix of best of breed technology. So the ability to integrate our technology with your data within your data pipeline and take advantage of it where we specialize. So looking at accuracy, so once again, I don't think anyone's going to argue that thematic and spatial accuracy are fundamental to land cover mapping. So we can look at national scale, for example, we often see anywhere between 80 and 90%, sometimes maybe even higher, like towards the 95% if we start looking at more specialized projects like Red Plus. Regional scale, oftentimes what we've seen is greater than 90 plus in terms of the thematic accuracy that they require. And then the spatial accuracy often depends on the resolution of the imagery that's being done. So this is an area that we once again specialize in. So accuracy is an area that PCI is really well known for. So we're industry leading when it comes to positional accuracy and orthorectifying and co-registering your images, which is not just important for the classification map you're going to ultimately publish, but also really important when you're trying to include additional layers of information like time series analysis, where those pixels need to be well registered with one another in order to properly extract that information. So once again, industry leading, we also have this new capability in order to achieve 1/10 pixel accuracy. So come talk to us a little bit more about that. Also proven thematic accuracy. So we're looking through one of the theses that was performed using Geomatica, both looking at random forests and support vector machines, which are the two machine learning classifiers that we have within our suite today. So using random forest, looking at, it was over 20 different mixed classes in South Africa in a variety of different areas, and achieved overall accuracy 94%, over 94% and 95% respectively. And then once again, you can also see the upper and lower confidence intervals for those same projects, or for that same project. Automation and time savings, another key area. So just to give a little bit of an anecdote, if we look at land cover mapping projects historically, and when we start to look and specifically look at the Korean project, if you go to their website, you can see that in 1990, the first time they kicked off this project, it basically took them 10 years to complete that land cover map. And then in subsequent years, it was faster, but still taking 2.5 years, until the most recent one, which was done in 2018, took 1.5 years. So, I mean, they've made significant improvements and gains in reducing the amount of time, but still 1.5 years, that's a very long time for a project. So this is where we can also help with our over 550 algorithms that can be automated through our Python API. And then also, if you look at our different technology stack, looking at our GXL capabilities for scalable processing and being able to work with large volumes of data, this is particularly important for national or continental scale projects. Also, breadth of capabilities. So once again, land cover classification is no longer just taking an image, running it through a classifier, and spitting out a classification result. I mean, we're long away from those days. And today it's a full data science project where there's a lot of data selection that goes on and removing poor data. So then there's all the way to the creating the analysis ready data. So this is an area that we've really put a lot of emphasis on and investment in terms of creating analysis ready data, such as our super registration capable of 1/10 pixel accuracy, the ability to perform radiometric and terrain and BRDF correction and atmospheric correction. So having all that capability to make sure that we can we can normalize the data and have a much more robust way of classifying the imagery on a large scale, as well as being able to create some of our value added layers, such as the time series maps. Data enhancing. So once again, all these aspects happen before the classification part, which is, and we have a new image fusion algorithm that I want to call out, which is basically it can fuse imagery together, both PAN and MS imagery, and create that higher resolution MS imagery, but retaining the spectral integrity of the MS imagery, the radiometric integrity of that image. So now it can actually be used in these classification workflows. And then the data engineering. So this is creating the indices and the spectral pre-classification. So these are all algorithms and tools that we have that can be highly automated, that can be chained together, and then can really help in that heavy lifting stage prior to the classification process and the modeling process. Integration is another key aspect. So with our Python API, once again, we understand that we are a best of breed technology for a lot of different areas, including creating the analysis ready data and a lot of that pre-processing heavy lifting working, including a lot of the machine learning classifiers. But there's still other great tools that you might want to plug into, such as TensorFlow for creating a deep neural network, Scikit for taking advantage of other machine learning and classification capabilities and predictive aspects, OpenCV, the Open Data Cube. So being able to plug our technology into these other best of breed technologies, both open source and commercial, gives you a lot of advantages when you're going forward to creating your data pipeline for generating your land cover maps. So before I finish, so I'm coming to the end. We're going to take a look at the demonstration soon. So I'm going to hand it over shortly. But I just want to kind of highlight where we see the future of land cover mapping going. So I had the opportunity to sit down with one of our senior scientists who's been long invested in this field. Many of you may be familiar with him, Wolfgang Luke. So I was able to pick his brain and start to understand some of the projects that he's doing and where we start to see the vision of land cover mapping. So we really start to see it being more of a live land cover map. So showing continuous change and having a continuous pipeline, really taking advantage of the Open Data Cube, which is now being implemented in many different national organizations around the world. And as you can see, it's just the idea of it's just going to be continuously feeding data into these maps. So another way to look at it is if we go back to our pipeline, we can see that we have, for example, this output product that we ultimately want, and it's the idea of just feeding data continuously through it in a more highly automated manner, and then just iteratively improving that pipeline and making sure. And the only way that this is going to be possible is through automation, is through collaboration, and making sure that those challenging pre-processing steps, we can automate as much as possible. And the more we automate, the closer we can get to this reality where it's more of a portal where people can go into, and basically it's just being updated in almost a real-time manner, as opposed to these discrete projects that get completed, say in a every few years, and then it's over. Because the moment, and this is something every land cover scientist or anyone who works in this field kind of understands, is the moment you commission the project, even before you're done, the data is already getting old. So the results are already getting old. So oftentimes these projects are finished a year, 2 years later, and then they're published, and that data is now a year, 2 years old. So getting to this point where we can push data through and just have that constant feed is where we see the future. We don't know exactly when we're going to get there, but this is where we see the future for land cover mapping. And then in order to help that same thing, taking advantage of infrastructures and technology of scale to showcase this, such as our GXL system, which is designed to handle and scale up based on the amount of image processing that's required for it. So once again, just going to bring it back before we go into our demonstration. So get started today. You can download a free 30-day trial. So a lot of the technology I was showcasing and talking about is available within our Geomatica product. So you can download a free 30-day trial and access it on your local computer. Once again, we specialize in photogrammetry, remote sensing, and image processing. You can also subscribe to our Geomatica cloud. So you can go to the website as you see at the bottom here. So it gives you 24/7 access from anywhere. We have flexible subscription options. And stay tuned. We'll be introducing very shortly a pay-per-use model as well, a pay-per-use option. So we're excited about that as well. And then for scaled processing and for high volume processing, feel free to touch base with us, inquire about our GXL solution. Both can be deployed on the cloud or on-prem, highly automated. So once again, please inquire within. And the last thing I'm going to mention here before handing off is our support model. So one of the big advantages also that we offer is we have great support, world-class support here. So you can go, we have a lot of self-serve options. So you can go to our help desk, our online help desk that's always available. You can access great tutorials, watch videos, access documentation, look at frequently asked questions. So a lot of your questions and curiosities will be answered there. And we have wonderful tutorials online, click by click, to show you that, including some tutorials related to our classification. Also, if you need to contact us, we have a 24-hour email response anywhere in the world. So we'll get back to you within 24 hours and with a detailed response. And once again, the thing that I think is most important about our support team is that these are trained experts that work for PCI. So these are people that are literally down the hall from me, down the hall from their scientists, down the hall from our engineers and developers, and they themselves are experts as well. So you're not working with an outsourced support group. You're talking to us directly.
Yeah, that's great, Sean. I'm glad you mentioned our support there. We have world-class support, and at the end of the webinar, I'm going to show everyone how to get in touch with them and show some other ways to engage with us using some other helpful online resources. That was excellent, Sean. Thank you for that. So we're going to get into the demonstration. Jason's going to do that. But before we get into that, I'd like to do another poll. So again, I'd like to ask for everyone's participation, and I'm just going to get it launched here. Okay, you should see the poll on your screen now. So the question we're asking you here is, what land cover mapping scale do you work with? So a few options here. We got global, continental, national, state, or province, or municipal or local government. So I'm just taking a look at the live results coming in. Thanks again for your participation in this. This is wonderful statistics. It looks like a majority. Oh, there's a bit of a tie with municipal or local government, state or province. Okay, this is great. Let the poll run just a little bit longer there. Okay. Thanks again for your input. Okay, I'm just going to close the poll down. 5, 4, 3, 2, 1. Okay, I'm just going to share the results with everyone here. Looks like a bit of a tie there with state or province and municipal or local government, with national being in third place there. Okay, this is great data. Appreciate everyone's participation in this. So with that, we're just going to get into Jason's demonstration. I just want to maybe outline right now what you'll learn with the demonstration. So Jason's going to show how to extract land cover classes from aerial imagery with an object-based approach. Okay, he'll also show you how to leverage our new robust random forest machine learning algorithm and how to automate your classification workflow on multiple images. With that, I'll ask Jason to share his screen and take over the demonstration.
Thank you, Mauro. Hello, everyone. Thank you, Sean and Mauro, for that presentation. As Sean explained, the pre-processing of the data is a large piece of the workflow in land cover mapping, and we have an array of tools for processing that can be utilized. However, what I'll be focusing on is the classification and accuracy section of the workflow. We can develop an automated land cover classification model and map by leveraging PCI's object-based classification tool called Object Analyst. Now, what everyone can see is my focus window, and I'll go into that in a moment. So what I want to show everyone today is more of a local and municipal use case. I will be utilizing the random forest machine learning method to generate a land cover map over Manotick, a small suburb south of Ottawa. And I'll be focusing on extracting specifically buildings, but also be extracting water, two types of different permeable surfaces, so grass and dirt, impermeable surfaces, so pavement and concrete, trees, and shadow. Now, of course, before I begin the process, I'd like to just show the final land cover map I generated with the random forest classification method. Here, we can see the result. And I've also downloaded a external building footprint file from the government open database, which I'll be using to perform the accuracy assessment, which generated, and I just have a little snipped image of it, around a 95% overall accuracy with the different classes. So now just to clarify, as Sean made mention, the new classification algorithm implements the random forest algorithm, but we have changed the name to random tree. So for this webinar, I will be referencing it as random tree. So now to begin the land cover classification, we should first familiarize ourselves with the data I'm working with. I'll be working with a clipped image of an aerial mosaic that contains RGB and NIR. And as the imagery was collected with stereo overlap, I was able to extract an DSM, a digital surface model, at the same resolution, filter it, and produce a height model for the image, which enabled me to set the ground elevation at 0 so I can get the actual relative heights of each of the surface features. So I would like to note then that the different types of data we're working with will have a profound impact on, of course, what features we're mapping. So for this instance, an elevation model is quite useful for focusing on building footprints especially. All right, so now that we have gone over the introduction of the data, I would like to go now through all the steps. So to begin the classification, we're going to open up the Object Analyst interface located under the Analysis tool. What we can see here is two different sections. On the left is a drop-down list containing all the different operations in a sequential list of all the steps to complete the classification. And on the right is the processing canvas, which will document all of our steps and then will be used for the batch classification operation in the GUI. Now, I've already generated the results, so what we can see all the different steps I've already run, but we'll simulate each of the steps in turn for this webinar. So without further ado, the first operation is the segmentation. The segmentation will segment the image into vector objects based upon the channel selected and the parameters set. We have a number of different parameters such as scale, shape, and compactness. The scale is the size of the segments. The shape affects whether the segmentation will look more towards the spectral properties or the shape of different features, and compactness will impact the elongation or compact of the vectors. Then we just point to an output location and a layer, and we can run the process. Now, before I continue, I would like to bring our attention to two other options, which is the SAR processing steps. We do support the processing of SAR imagery, and in a number of different operations, we have SAR-related unique abilities. And lastly, if you have a large area and you just want to focus on a number of smaller areas of interest, if you have a supplied vector file, you can just select the use area of interest and apply the classification or the segmentation and classification to those areas only. So once we have run the segmentation, if we click the add and run, it will be loaded to the processing canvas, such as what we see on the right. And the first result is displayed right behind. What we can see, if we zoom into to this little neighborhood over here, all the different features have been segmented in different objects across the entire image. And these are the segments, these objects are what we're going to extract statistics from, classify, and merge and use for the final features. So the next operation is the attribute calculation. Here, this step is where we're going to collect the statistics and the attributes from the underlying imagery. This includes both statistical, geometrical, vegetation indices, texture measurements, and if you have polarimetric SAR data, SAR attributes as well. What's important to note is this process can be run on the segmented image, but also enables the user to acquire statistics and attributes from additional images and different types of data types of imagery as well. As such, a user can leverage the data engineering to work with multiple resolution images to update their attribute model to then produce a robust training model for batch classification and automation. Okay, so once the user has run through the attribute calculation, we can then go to the next step, which is the training site editor. The training site editor, I'm just going to select the training vectors. Generally, when running through the process from beginning to end, all the different input parameters are automatically set. However, because I have already run through the process, I'm going to have to manually set a few input parameters. Nonetheless, once the training sites, or once we open up the training site collection, we can collect training sites which will be used to, of course, train the classification algorithm. This can be either done manually by selecting and assigning. I'm just going to drag over here. Wonderful. This can be done either manually by selecting and assigning each of the segments to a specific class, or automatically with a ground truth import option. Now, the advantage in this workflow is that in the same training site collection window, we also offer the user to collect segments that will be used for the accuracy assessment. These accuracy segments that are collected will not have any input on the classification algorithm itself, but will be used to evaluate the accuracy of the result. And so I want to just show how simple it is to manually collect a few training or segments for training and accuracy. All we need to do is, for instance, zoom into a specific area, identify a class. I've already created a number of classes. So for this instance, I'll select building, identify a segment that covers that class. So I'll select this group of segments right here. Perfect. And I can either assign it to the training or the accuracy assessment. And once I've selected, I just click assign, and the color has changed to represent the class and the training count. I can do the same thing with the accuracy by selecting some impermeable surface features, selecting the accuracy assessment, selecting the correct class, and assigning them as well. So one thing to take note is that a user should make sure that they collect their training sites represent the different types of features for each class. So for instance, in buildings, not only focusing on one type of building feature. So you want to have a good variety to help improve the classification algorithm. Another point I'd like to bring attention to is the class outlier function. Now, when running classification algorithms, class outliers can cause negative effects to, or can cause errors in the classification. So this class outlier will search and identify any segments that were collected that may be represented as outliers, enabling the user to go assess them, and if required, either remove the training site or collect additional new training sites to help improve the model. Wonderful. I'm going to just close. And again, we can have the ground truth import option if we have an external ground or external feature, such as building footprints. We can import them in either for training purposes or for accuracy assessment. Now, once we are satisfied with the training sites that we've collected and accuracy sites, we can then select the next operation called supervised classification. Here, I'm just going to select the, I'm going to select the layer, the segmented layer that we created. And what we can see is it displays all of the attributes that we collected in the attribute calculation step. And the strength of the random forest algorithm is that it will analyze and rank the different features and exclude those that are not important. For this purpose, I'm going to select all. I'm going to deselect area and perimeter, but I'll leverage all the other attributes I collected previously, such as statistical, vegetation indice, and click OK. Now, the next step is to populate the training field, which is where we collected the training sites and accuracy sites. Provide it a new output class name. So I'm going to call this random forest webinar. And now I'm going to select the classifier. So instead of SVM, I'll be choosing the random trees, which leverages the random forest classification algorithm. Now, we have exposed a number of the hyperparameters, the ones that have the most impact or significant impact on the results. But those parameters that are not visible are actually optimized based upon the data that's being processed and the parameters that are being set in this viewer. Once the user is satisfied with their parameters, they can then save the training model, and this training model will then be used for the batch classification in either Python or in GUI itself. So all we need to do is select the training model, select that we want to save it, browse to a different location. Let's call this training model webinar, and all we need to do is add and run the process by clicking this icon at the bottom. But of course, for the interest of time, I've already run through the steps. I'm just going to turn off the training layer and open up the classified layer. Here we can see that all the different segments have now been classified based upon the training sites that we collected and the parameters set. We can then perform an accuracy assessment by again selecting the layer, the segmented layer, selecting the channel, choosing the classification field, which I created called random tree before. The reference field that contains the accuracy sites we collected. So I'm going to select the training one, which contains both the training and the accuracy segments. And I'm going to just select the generate report. It's just processing on my other screen. Wonderful. Here we go. So we have a sample list of all the different training sites, a confusion matrix, and an accuracy statistic of the different types of accuracy classes we collected. Just going to close that. Now, if the user finds that there are errors, either the accuracy assessment is not sufficient to their requirements, they can either go back and collect additional training sites, or they can leverage our rule-based classification operation to develop rules and conditions that will refine and change the different types of classes, or refine the classes. However, for the purposes of this, we're just going to go to the next step called the post-classification editing. And this is when the user is finally satisfied with their results. They can then merge all the different segments into a larger objects, which can of course be employed for further analysis. All we need to do is select, again, the vector, choose the class we want to dissolve into, run the operation, And the final result, I'll zoom out for this one, is the land cover product. Now that we've created this dissolved classification land cover map, we still have that training model, which we can now leverage to use on other data sets. So this can either be, of course, done in the batch operation. So that is the last operation step in the object analyst window, or in Python interface, or Python GUI, or sorry, our Python scripting. And we do have a number of examples of that on our help documentation and our help website. So all the user needs to do, I'm just going to prepare the parameters, is select a location that contains their images they want to work with. For this instance, I'm working with Gananoque, or images over Gananoque and Kingston. Select the folder location. Select an output location. Put segments. Choose a prefix if I want to change the name, and of course the search pattern depends on what type of file format your images are. They could be TIFFs, they could be PIX files, which are our own PCI file format, and then select the training model. All we need to do then is add it to the canvas, which we can then go through our processing canvas history and choose the different operations that we want to use for the batch classification. It's a very simple step here. All you need to do is right click on the operation, add to, batch classification, and do that for the attribute calculation and supervised, and then right click on batch, select run, and it will iterate through each of the images, segmenting, attribute calculation, and classification to produce, and I have my final example, here's the land cover map for our area in Geomatica. We have it over Kingston and Gananoque. So this is just one example on how you can leverage Object Analyst random tree or random forest classification algorithm to generate land cover mapping.
Well, very cool, Jason. Thank you for that. That was a great demonstration. Let me just take over presenting my screen here. Okay, should have that. Okay, wonderful. So I just want to go over what we just learned there, what Jason showed you in the demonstration. So Jason showed how to extract land cover classes from aerial imagery with an object-based approach. Showed you how to leverage our new robust random forest machine learning algorithm. And Jason showed you how to automate your classification workflow on multiple images. So that's wonderful. Thank you, Jason, for that. So we're going to get into some of your questions right now, but before we do, I just want to go over a few of those online resources that I mentioned before. Jason also mentioned during his demo about our help center, where you can access some scripts. We've got lots of stuff there. Head over to support.pcigeomatics.com. There you'll find lots of tutorials, some common questions that we usually get. Our webinars are on there. Lots of training, case studies, and articles. This is a great resource. I definitely recommend that. And I just want to mention we have a new tutorial that we've just added to our tutorial section there. It's a classification tutorial with random forest, so I would definitely recommend checking that out. We also have a developer zone at dev.pcigeomatics.com. This is where you can share scripts. You can take a look at our scripts. We've got lots of the documentation there, more tutorials and videos. Another great resource for you to check out. We have also tons of training, free training on Udemy. So if you head over to pcigeomatics.com/training, we have about 5 courses there. These are full training courses. They're free training. You can register. They're video based, so very easy to follow. You can get in. You can get in touch with the instructors. You can communicate. It's a great place to access some free training. And of course, we have our YouTube channel. So all of our webinars are on there. We have tons of videos to share with you guys, and we can interact on YouTube as well. So check us out on YouTube. So speaking of webinars, we have all of our past webinars are also on our website, pcigeomatics.com/webinars. But you can also check out our upcoming webinars there as well. Okay, so we're just going to get into some questions and answers. I've been keeping an eye on the questions panel throughout the webinar. I noticed Sean has been answering questions on the fly. We really appreciate those questions. We're going to try to get to. I think Sean has gotten to most of them. I'm not too sure. Let's take a look here.
Yeah, thank you, Mauro.
Yeah, I see. We have quite a few questions here.
Quite a
I
few
don't know.
questions. Yeah, absolutely. We can definitely get to a few questions. We only have a few minutes left in this hour, so I want to make sure everyone has an opportunity to get back to the day. So if we don't get a chance to answer your question in this webinar, we will follow up with you. But I think we have time for at least 2 questions before we conclude this webinar. So let's find so here's one which is asked, which classifier gives better accuracy, SVM or random forest? So actually, we had a study that was commissioned recently that where they analyzed both the SVM and the random forest on the exact same data sets, and it actually showed in this case the SVM in this particular example produced a slightly better result, about I think it was around 95 overall accuracy or 95% overall accuracy versus like 94. So it was very, very close. It also very much depends on the classes you provide, the features you include. One of the benefits of the random forest is that it's very robust. So it's by design, it creates a lot of different decision trees and potentially hundreds of decision trees. And then basically takes the average of those different decision trees in order to create a result. So it's a lot more, it's considered one of the most robust and consistent algorithms, machine learning algorithms in the market. So hopefully that helps answer your question. I think it very much depends on your data and your features, but they're both very, very good machine learning algorithms. Okay. So this won't be one of the questions, but it's just funny. Someone said that random forest algorithm is not only for forest applications, like its name may suggest. That is very true. It is actually a data science machine learning algorithm that's meant for general purpose data science, not even can be used on things even outside of imagery. And so absolutely, it's just the name they gave it because it really is combining multiple decision trees together. So that is definitely
yeah, I think that's what I thought originally too, Sean?
Yeah. So let's just see for one last question. As I said, if we don't get to your question, we will follow up. So the question, I think this one could be Jason, if you can perhaps answer this, is the accuracy assessment also available? I guess the one that you showed for the thematic accuracy, is that also available in the Python API?
For that accuracy assessment, I could confirm, I believe so, but I can confirm with our developers as well.
Okay, so maybe that's one of those ones we'll follow up again on, but I also do believe it's available, but we'll follow up with you to verify. Now, there's a lot of other great questions, and my apologies that we aren't able to answer all of them, but we're at the top of the hour now, so we want to let everyone be able to get to their next meetings. And once again, for myself at least, thank you very much. And Mauro, I'll let you conclude things here.
Great, yeah. So we do have a lot of questions there, but we have run out of time. But we will respond to all those questions. Give us a bit of time. We appreciate the input. That is all the time we have for today. I do want to thank Sean and Jason for your awesome presentations. Thanks for joining us, and I want to thank all of you for joining us during this webinar. Thanks for participating in the polls, for asking your questions. We really hope you found this webinar to be valuable. The webinar is over, but please don't hesitate to engage with us. Let's keep the conversation going. Please reach out to us on social media. Contact our amazing support team. We always appreciate your questions, and we look forward to interacting with you. So with that, I'd like to say it's been a pleasure being with all of you today. Until next time, take care and bye for now.